Here we are in section 5.5, and in problem number 7, we're asked to identify each one of these four equations as either linear or quadratic. So let's take a look at this. I'm going to say that the first one is linear because the highest exponent here is a 1. In the second one, I'm going to say this one is quadratic because the highest exponent here is 2. In number 3, I'm going to classify this one also as quadratic because the highest exponent is 2. And in D, this is a little tricky here. Be careful. The exponent is on the constant, not on the variable. So the highest exponent on the variable here is a 1, so that's going to make this one linear. In problem number 9, we're given this equation and this solution, and we're asked what has gone wrong. Well, I think what's gone wrong here is that we're given two factors, right? We're given this factor here and this factor, and we're saying only one of those is equal to 0. The zero factor property says if you have a collection of factors and the whole thing is equal to 0, that each factor could be 0. So it looks like we've forgotten to write that the x is equal to 0 here. So what I'm going to write here is that this is going to be good if the solution set is the 1/7 as well as the 0. In number 11, we're going to solve this equation by applying the zero factor property. So we have this factor times this factor giving us 0. So what could happen here is we could get a plus 9 could be 0, or a minus 12 could be 0. And now we can solve each one of these little linear equations by doing this. Let's subtract 9. So we'll get a equals negative 9. Over here, we'll add 12. A is equal to 12. So our solution set, we're going to say, is negative 9 and 12. Now here, I don't think we need to go through this from here on out. As long as we have two factors, or 3, a collection of factors giving us 0, we can just read off the solution. You know how you're going to solve a linear equation, right? You're going to do the opposite. So I got the opposite of 9. I got the opposite of 12. So I can just read these things off. Let's do a few more and we'll see what we mean. In problem number 13, we've got two factors giving us 0. So what we're going to do is use the zero factor property, and we can write this. 2m minus 9 must be 0, or m minus, let's get a minus here, m minus 6 could be 0. One of them's got to be 0, right? We're multiplying two numbers together and we're getting 0. One of them has to be 0. It could be the first one being 0 or the second one being 0. Now let's solve these linear equations. We're going to do this kind of quickly here. Here's what we're going to do. In the first one, what do? You're going to add 9. So we'll add 9. That'll make it look like this. And then we're going to divide by this 2. Right? So to solve these equations, we do the opposites. I do the opposite of this, subtraction. Opposite is addition. I do the opposite of the multiplication, which is a division. So I'm going to get m equals 9 over 2. Over here, we're going to add 6, so I'll get m equals 6. So our two solutions here are m is equal to 9 halves and 6. But I think I can see that right here at the beginning. Back here at the beginning, I'm just going to do opposites. As long as I have these factors giving us 0, I can just do the opposite. Change the sign of the constant, divide by the coefficient. Positive 9 over 2. Change the sign of the constant, positive 6, divide by the coefficient, which in this case is just 1, so I just get 6. In problem 15, let's think the same way we did in 13 and 11. What I'm going to do is I've got these factors here giving us 0. So I'm just going to undo. I'm going to do opposites here. So what I'm going to get here is x equals, now, do opposites. Change the sign of the constant, right? I'm going to add 5, and then I'm going to divide by 2. So I'm going to get 5 over 2, and from this factor over here, I'm going to get negative 3, right? Change the sign of the constant, divide by the coefficient. So I'm going to get negative 3 over 3, which I can reduce. So let's say our solution to this equation is 5 over 2 and negative 1. We'll use the zero property here again in problem 17. We've got this factor and this factor giving us a 0. So each one of these could be 0. So what I'm going to write here is that this t could be 0, right? That t could be 0, as well as the 6t plus 1 could be 0. And what's going to make this 0? Well, just think about solving this equation. There it is right here. Subtract 1, divide by 6. So in other words, what we're going to do is change the sign of the constant, divide by the coefficient. So we're going to get negative 1 over 6. There's our two solutions. In problem number 20, we're given these three factors, 5w and 11w plus 6, and set up as an equation. They're equal to 0. Now, by the zero factor property, at least one of these has to be 0. So could it be the 5? No way. 5 is 5. It's not 0. But w could be 0. So what we're going to get here is we're going to get w is equal to 0, or this factor here could be 0. What's going to make this 0? Subtract 6, divide by 11. So we're going to get negative 6 over 11. So there's our two solutions. And let's just say something again about that 5. The 5 has no effect on our solution set here. 5 is not going to be equal to 0. What we could do is divide both sides of this equation by 5. In that case, the 5 divided by 5 here would be a 1, and 0 divided by 5 is 0. So we'll just get w times 11w plus 6 is 0. Now in number 21, we're given these two factors, which happen to be the same, being 0. So what we're going to get here is that r is equal to, now, from this one, r minus 2 is 0. That means r must be 2. So we're going to get r equals 2. But from this one over here, we also get r equals 2. So we don't need to write it twice. The solution here is that r is equal to 2.